Well, hello there, ladies and gentlemen. Hope you guys are doing all right. Hey, man, we're already on lesson number 19. We're going to be talking about solving equations using inverse operations when we have more than one x, or you know, more than one unknown. They can be on the same side of the equation. They can be on different sides. For example, I just did a Google search solving equations with the variables on both sides, like this one right here. See, it says 5 minus 2, 3 minus x equals 4x plus 10. That one right there. Oh man, we could do that. Or how about solving equations with, let's see here, more than one variable. Oh yeah, let's see here. Let's see what we can come up with on this one. Oh, that's not what we were talking about. But that works too. Yeah, let's talk about that one right here. How about that green one right there? I'm going to write this one on my paper. We'll get started right here. 6x minus 2y minus x equals, that's weird, 6 plus 4. I'm just going to write that as 10. All right. So, anyway, that's what we're going to be talking about today. Let me go ahead and get ourselves started up right here. Oh, man. No, not that one. There we go. All right. So, check this out. These are the two kinds of things we saw. These are the things we're going to be able to do. Here's the number one overarching idea. If you have more than one x, say you're solving for x or whatever, right? If you have more than one thing that you're solving for, right? If you have more than one x, your first job, your very first job has to be combine them into one. Has to be. So for example, if you had say 5x minus 2x plus 1 equaled, I don't know, 0, for example. Do you see, if we want to get x by itself, we first have to get those x's together. So here, we would have to subtract, or sorry, distribute that negative 2. That would give us negative 2x. This would give us minus 2. Then we'd have to combine these together. That's 3x minus 2 equals 0. So x is going to be 2/3 when you're all said and done. So that's your first order of business. Before you can start using inverse operations, before you can worry about any of that SADMAP stuff, you have to get those x's together first, no matter what. So if they're in a group, you got to get them out of the group for whatever reason they're in the group. This one's in a group because of the 2 that's multiplying. If it had, yeah, no matter what, you have to get the x by itself. See it. Let me see another example of that right here before we get into this one. So let's say we had x plus 2 over x equaled 5. Oh, look at that. So here, again, we have two x's, right? Now, one of the things we talked about is how if you have an unknown in the denominator and you want to solve, you have to get it out of the denominator. So the way you do that is with multiplication. See, really this is x over 1, so these two reduce and make just 1. Okay, now, here's the next big idea that's coming, right? First order of business, get those x's together on one side, combine them. The second thing is, you see how these x's are on opposite sides? We have to get them together first. Don't even worry about where this 2 is or anything like that. You get the x's together first. Now, here we have to move either this, we either have to subtract 5x from both sides, or we have to subtract 1x from both sides. So here's the best advice. Move the smaller one. So here, you see how x is smaller than 5x. We want to get rid of that one. So what we're going to do is, in this case, we're going to subtract x from both sides, like this. You see? That makes 0. 2 equals 4x. So 1/2 is x. Do you see? So those are our two big ideas. Number one, get all your x's together. Number two, if you have to move a term with an x from one side to the other, and you have to make a choice, move the one that's got the smaller coefficient. 1 is smaller than 5. Move that one. Do you see? All right. Let's get into this. So check this out. We have an x that's stuck inside of a group. It's inside the group because of that minus 2. Now here, we could divide everything by 2, but it would be the 5. It would be this whole thing, that, and that. Since 2 doesn't go into 5, I don't want to do that. I think it's going to be easier to just, oops, sorry. It's going to be easier, oh my gosh. dog is outside pacing around in the hallway and distracting me. You should. It's funny how little distractions like that can cause such a trouble. Okay. So anyway, since I made a silly mistake, let's go back and double check, right? That's negative 6. That's plus 2. So we're good. All right. Now, these two make negative 1 plus 2x equals 4x plus 10. All right. So now, you see how we have an x on the left, we have an x on the right. We clean this up because that's super easy to do, right? Uh, this is smaller than that. So what I'm going to do is I'm going to subtract 2x from both sides. At the same time, I could have subtracted 10, but I did it as a separate step. So here's what I did. To go from this step to this step, what I did, I just subtracted 2x from both sides. That makes 0, that makes 2x. I could have at the same time subtracted 10 and skipped this step entirely and gone there. But either way, that's how it works. Now over here, it's true. If we're going to solve, let's say we're going to solve for x, right? It's true we don't know what y is, but it doesn't even matter. It doesn't even matter. I'm going to get these x's together. You see, you can rearrange it without changing any of the values. It's on the same side of the equal sign, so we're not using inverse operations here. So this is 5x minus 2y equals 10. So I'm going to add 2y to both sides, right? You get 5x equals 2y plus 10, and then divide both sides by 5. Do you see? So x is equal to 2 over 5y plus 2. Always reduce. Man, there we go. So anyway, big idea. If you have more than one x, right? Got to get those x's together. That's your first order of business. How you do that depends on the problem. You got to read it, see what it says. Second big idea. If you have an x on each side of the equal sign, use inverse operations to get them together, and you want to move the smaller of the x's. So like in the case we did here, we had a 1x and a 5x, we moved the 1. Over here we had another situation, let's see, on this one, we had another situation where we had a 2x and a 4x. Two smaller, so we moved the 2. Hope it's been helpful. You guys are killing it.